This video concerns the laws of logarithms, which are closely related to the laws of exponents. So we'll start with a brief reminder about laws of exponents. The first law of exponents that we need to use is that some base b to the m power times the same base b to the n power is equal to b to the m plus n power. For example, 2 to the third times 2 to the fourth is 2 to the 7th, and that of course is just because this is 3 2's multiplied together times 4 2's multiplied together is in fact 7 2's multiplied together. So the product property of logarithms says much the same thing. Log base b of m plus log base b of n is equal to log base b of their product, m times n. So let's do an example with numbers. And before you move on to the next page, make sure you take notes on this. This is one of our very important formulas from this night's video. So here's an example. We have log base 2 of 8, that's saying to us 2 to what power is 8, plus log base 2 of 4, 2 to what power is 4, is equal to log base 2 of 32, 2 to what power is 32, where we notice, of course, that 8 times 4 is equal to 32. And let's just do a quick check to make sure that this works. 2 to the third power is 8, 2 to the second power is 4, and 2 to the fifth power is 32. So it does actually work out because 3 plus 2 is 5, I hope. So here we have log base 3 of 7, and to that I'm looking to add log base 3 of 5. Now neither of these works out nicely, but it doesn't keep me from combining them and saying, okay, 7 times 5 is 35, so this is going to be log base 3 of 35. And that doesn't work out nicely, but that's okay. It's still a true statement. Now the absolutely critical thing in this is if you look through, the bases are the same for all of these. Just as up above with our example, the bases were all the same. Just as when we did it with letters, the base b was always the same throughout all of our logarithms. So we must always have that base the same. So we're going to go on and look at another property of logarithms, but as before, we're going to look at the property of exponents first. So we should recall that b to the m power divided by b to the n power is equal to b to the m minus n power. Again, the reason that this is, let's look at it with some example numbers. If I've got b to the fifth divided by b cubed, well, that's b times b times b times b times b divided by b times b times b, and 3 of these cancel out, just leaving me with b squared. So that's the reason for that property of exponents. Now let's look at the law of logarithms that goes along with that. So again, in this rule you will notice that the bases always have to be the same, and this has that when we've got log base b of m minus log base b of n, that's equal to the quotient log base b of m over n. This is another one of our important formulas from this section, so make sure you write this down in your notes before we move on and look at a couple examples. So again, we've got the rule with variables written right up here, and here we have one example similar to our example with from the product property of logarithms. We've got log base 2 of 32 minus log base 2 of 8 is equal to log base 2 of 4, where 4 is 32 divided by 8. And each of these we can evaluate pretty easily. 2 to the fifth power is 32, 2 to the third power is 8, and 2 to the second power is 2. 2 to the second power is 4. So indeed, this equation does work out fairly nicely, because last I checked, 5 minus 3 is in fact equal to 2. And as before, each of the individual logarithms don't need to work out terribly nicely for this to be okay. We could have log base 7 of 28 minus log base 7 of 2 is going to be equal to log base 7 of 14, because 14 is 28 divided by 2. And again, this is closely related to the property of exponents that I stated a little while ago. So there are a couple examples with that property. And again, we do note that throughout all of these equations, well, through this equation the base is 2 all the way through this equation the base is 7 all the way through, and through this equation the base is b all the way through. The same base is used throughout in order for these properties to apply. So here's another property of logarithms, that log base a of some number a raised to the p power, so here p is the power of a, is equal to p times the logarithm of log base b of a. And if you're curious about why this one is true, well, remember that this one is log base b of a times a multiplied together p times, and that this is just log base b of a plus log base b of a plus, and we add those together, p times, which is exactly what we have right here. And this is the case from here to here is the case because of that product property of logarithms. So if you're curious, that's why that is true, and if not, I'm not going to test you on that explanation, but there it is. So now we'll try it with a couple examples. So we have log base 2 of 8 squared, and by this power property of logarithms, we've got this is 2 times log base 2 of 8, which is 2 times 3, because 2 to the third power is 8, so that's just 6. That is one way that we might apply the power property of logarithms. So please make sure you have this formula in your notes before we move on and take a look at another property of logarithms. So these are our two inverse properties here. Log base b of b to the x is equal to x, and b to the log base b of x is equal to x. Notice again that our bases have to match. So for example, we might have log base 8 of 8 squared is just equal to 2. Or here we might have, similarly, that 8 to the log base 8 of 2 is equal to 2. Essentially what these properties are saying is something that we already knew. 8 to the something power, what we're looking at here, 8 to some power, and log base 8 undo each other. Again, log base 8 and 8 to the something undo each other, and just leave the 2 in each instance. So those are the inverse properties of logarithms, and I know we went through those pretty quickly, but we will come back to a few examples at the end. And based on some previous properties, I think this one actually makes a lot of sense, because using our power property, this would be x log base b of b, and we remember that this says b to what power is b? Well, b to the first power, so that's just x times 1 is just x, which is what that property says. A similar argument can be made for our other inverse property. So I know that we've just gone over 4 properties pretty quickly, but probably what's going to help you most is just to think of these with some examples of simple numbers if you're having trouble remembering them. For example, if we want to say, okay, log base 2 of 8 plus log base 2 of 4, well, we know that this is 3, this is 2, so this is going to equal log base 2 of 32, and this equals 5. So that's how we could check that. Now I can almost guarantee that somebody is going to write something like this on a quiz or test, where they say, okay, these two logarithms are multiplied together, so I'll add 8 plus 4, and they'll give me 12. But a quick check of the numbers should convince you that this is not true, because log base 2 of 8 is 3, and log base 2 of 4 is 2, and we don't even have a number for log base 2 of 12. That's not a nice number. It's certainly not 6. So this definitely can't be true. So again, you can always check this with, you can check your properties with some nice numbers like this. Make sure that it works out when you do so. So I'm going to work out a few examples, and I will give you a few similar examples to prepare for class tomorrow. This first problem is a problem that really is asking us to use that product property of logarithms and say that this is okay, log base 4 of 2 times 32 is 64, and this is just equal to 3 because 4 cubed is 64. So that's what that problem would be looking for. So this here is another problem that would ask you to use laws of logarithms to simplify before solving. And I know that this is a problem that you could do without simplifying first, but we're not going to approach it that way. We're going to say that by the quotient property of logarithms, this is going to be log base 2 of 8, where 8 is 32 divided by 4, and this is just equal to 3 because 2 to the third power is equal to 8. So here's a problem that's just asking us to use that power property of logarithms to say, okay, this is equal to 3 times log base 5 of 1/5. Then we need to ask ourselves, 5 to what power is 1/5? Well, that's 5 to the negative first. So this is 3 times negative 1. So the solution to this one is just negative 3. Again, this is because 5 to the negative first is equal to 1/5. Here's an example that's asking us to use that an inverse property of logarithms to say that this is just equal to 3x plus 1. And you don't even need a property to tell you this if you think about what this says. This says 8 to what power is going to give me 8 to the 3x plus 1 power? Well, 8 to the 3x plus 1 power gives me 8 to the 3x plus 1 power. And here's another one that asks me to use that other inverse property of logarithms. Again, this answer would just be 27. And this one's a little bit more difficult to see exactly why it should be true. But if we look at this, right, this says 2 raised to what power is 27? And I'm raising 2 to that power has to give me 27. I hope you can see that. If not, keep working with it for now. That is, again, part of the point of logarithms is that 2 to the and log base 2 undo each other and just give us the 27. Here are 4 questions for you to prepare for class. For problem 1, please combine these to a single logarithm and then evaluate. Same instructions for problem 2. For problems 3 and 4, go ahead and use some of our properties of logarithms to evaluate those expressions. I will see you tomorrow.